In this video, we're going to review the topic of fractions at National 5. Often these questions can appear at the start of a paper 1 just to try and build your confidence. It's a really important skill that we take on to higher as well, so just thought it'd be a worthwhile recap for today. I'd recommend if you could copy something like this down onto your page, and we're just going to branch off with 5 examples of the sort of questions that you can expect to see. Okay, so the first example is a problem involving addition. So you need to remember that when we are adding and subtracting fractions, we need the same denominator. That's the most important thing. When we add and subtract, we need the same denominator. And hopefully, as you look at this, you can see that here our denominators are not the same. We've got eighths and thirds. So we're going to eventually want to make sure we have the same denominator. Before we do that though, we need to make sure that any mixed numbers are written as improper fractions. So I've got 3 1/8 here, so I'm going to rewrite that. So 3 1/8 is going to be 8 times 3 is 24, plus 1 is 25. Okay, so I've done my first step. I have written my mixed number as an improper fraction. I now want to make the denominators to be the same. So I need to have a look at my denominators. I need to think, okay, what's the lowest common multiple of 8 and of 3? And in this case, it's 24. Okay, so I then need to think about, okay, to get from 8 to 24, to get from here to here, I've multiplied by 3. Therefore, I need to multiply this by 3. 25 times 3, 75. To get from here to here, we've multiplied by 8. So we need to multiply this by 8. 2 times 8 is 16. Okay, once we've got that, we can go ahead and add. That's going to be 91 24ths. If you wanted to leave it like that, that's absolutely fine. Always check if you can simplify it. It doesn't look like this can be simplified. I'm not 100% sure though. So let's just think about it. I'm going to write this as a mixed number. So I'm going to think about my 24 times table. So it goes 24, 48, 72, and then 96. So 24 goes into this 3 times, and it'll be 21 24ths. Oh, no, it wouldn't. It would be 19 24ths. Because that's going to be 72 plus 19. Okay, so you can leave your answer like so, or if you want to do it, you could write it as a mixed number where appropriate. Okay, so main thing, if you have any mixed numbers, write them as improper fractions. Make sure you have denominators the same when adding and subtracting. That was example 1. What have we got for example 2? Example 2, we've got some subtraction. Hopefully when you look at this example, you can immediately see that it's going to be negative. Because if I've got 1 subtract 3, well, it's going to be, I'm taking away a bigger quantity, so we're going to expect a negative answer here. First thing we're going to do is we're going to change to improper fractions. So 1 times 5 plus 2 is 7, so I've got 7 fifths, and that's 4 times 3 is 12, plus 1 is 13. Once we've done that, we are going to get the same denominator. We want to find the lowest common multiple of 5 and 4. It's going to be 20. From 5 to 20, we've multiplied by 4. We need to multiply this by 4. From 4 to 20, we've multiplied by 5. We need to multiply this by 5. 13 times 5 is 65. Sometimes with these problems, like in an exam paper, you might need to do a wee bit of working at the side, because it would come up in a paper 1. Okay, so then hopefully you can see, we're going to get a negative number here. So 28 minus 65. So what's that going to be? We're going to take away 60, take away 5. That's going to be 32 minus 37 over 20. I think 37 over 20. 58, yep, minus 37 over 20. If you wanted to, that could be minus 1 and 17 20ths if you wanted to. But this here would be absolutely fine. Okay, so once again, main idea, change to improper fractions, get the same denominator, and then proceed from there. Okay, that was example 2. Example 3, we've introduced this problem here. 2/3 of 9/10. So big thing here is this word of. You need to know that in the context of fractions, and I should copy this down, is that of means multiply. So when we see a question that says find something of something, that means we're going to multiply. Okay, so the first thing we're going to do is we're just going to rewrite this problem as a multiplication problem. Okay, so we've rewritten it as a multiplication, and the nice thing with multiplication is you do not need to have the same denominator. When we multiply, you've got two roots. Root 1 is you multiply the numerators and multiply the denominators. What's that going to be? That's going to be 18 over 30. And they can both be simplified. They're both in the 6 times table, and that's going to be 3/5. That's root 1. Multiply numerators, multiply denominators, and then simplify. Root 2, it's the option I use, is I look at my diagonals. And I think, okay, is there anything, is there a common multiple, is there a common factor with my diagonals? So I look at my first diagonal in 2 and 10, and both of those are in the 2 times table, so I can divide both of those by 2. I look at my other diagonal, 3 and 9, they're both in the 3 times table, I can divide them both by 3. Once I've got that, I then just read off what I've got. I've got 1 times 3 over 1 times 5. Okay, personally, I would always use this approach, because sometimes any issues here, you might get quite some problems, some numbers might be quite difficult to simplify. So I would always look at the diagonals first. Okay, 2 more to go. We've got some division this time. 3 2/7 divided by 5/14. The first thing I'm going to do is I'm going to change that mixed number to an improper fraction. So 7 times 3 is 21, plus 2 is 23. So 23 over 7 divided by 5 over 14. Okay, so we don't need the same denominator here. It's only for adding and subtracting. So when we divide fractions, you need to remember that we flip the second fraction and divide becomes times. Okay, that's the main thing you need to remember when we are dividing fractions. So I'm going to go ahead and use the second root here where I'm multiplying. I'm going to look at my diagonals. 5 and 23 I can't do anything with, but 7 and 14 I can do something with because they're both in the 7 times table. And then I just read off what I've got. 23 times 2, 1 times 5 is 5. And I'll write that as a mixed number. What's that? 9 1/5. Okay, so when we divide fractions, we flip the second fraction, divide becomes times. Okay, final example. It's this example here. I'm going to zoom right in. 1/4 plus 3/8 of 1 1/5. This is very typical with what you see at National 5. This might be like a question 1 scenario. Very common this will come up, and a lot of pupils trip up because what a lot of pupils do is they just do this bit here and then they deal with the part at the end. However, you need to remember what this word of means. So the first thing I'm going to do is I'm going to rewrite this. Plus 3/8 multiplied by 1 1/5. Okay, and sometimes just writing that might make things a bit clearer, because now we need to think about, well, what part do we need to do first? Do we need to do the addition or the multiplication? And you should know by now that we absolutely have to do the multiplication first due to the order of operations. So we're going to evaluate this part here that I've highlighted. So I'm just going to bring this quarter down. First thing I'm going to do is I'm going to change that mixed number to an improper fraction. That's going to be 6 over 5. Okay, I've done that. I'm still going to keep this highlighted to show this is the part we're doing first. Okay, so let's look at our diagonals this time. 3 and 5 I can't do anything with. I can do something with 6 and 8 though. They're both in the 2 times table. 2 goes into that 3 times. 2 goes into that 4 times. Okay, so then I'm just going to read off what I've got. 3 times 3 is 9. 4 times 5 is 20. Okay, so now I've just manufactured it into a case where I've got an addition problem. And with addition problems, we need the denominators to be the same. They're different here. So I need to think about, okay, what's the lowest common denominator of 4 and 20? What's the smallest number in the 4 and the 20 times table? Well, it is 20. So I'm not touching that second fraction. But I'm rewriting this first fraction. To get it from 4 to 20, we multiply it by 5. So I need to multiply 1 by 5, which is going to be 5. And then we can just read it off. That's going to be 14 20ths. And always check your final answer, because this one can be simplified. They're both in the 2 times table, so you would always be expected to have your answer in its simplest form. Okay, so there we just had a look at 5 examples with fractions at National 5 level. When you're adding and subtracting, you need the same denominator. When you're multiplying, I recommend looking at the diagonals and simplifying. When you're dividing, you flip the second fraction, divide becomes times. Remember that of means to multiply. And finally, sometimes you can get fraction questions that are mixed in with order of operations, so you might need to do any operations within brackets first and so on. Thank you very much.